Hello. Okay, so today's problem comes from Hillsboro, Oregon, and it involves a quadratic function. The function we've been given is f of x equals x squared minus 6x minus 9, and we've been asked to find the zeros, and we've been asked to do that using this by completing the square. Now, the zeros are the x-intercepts if we were to graph out this function, and because if we let the function equal 0 to find the zeros, that's basically it. We're saying where is this function equal to 0? And remember, if the function itself, if f of x is 0, that is where y is equal to 0. In other words, where the graph crosses the x-axis. We start this method by adding 9 to both sides so that we can get that c term out of there. So we end up with 9 equals x squared minus 6x. And now to complete the square, we're trying to determine what number could we add in this third spot that would make x squared minus 6x plus what would give us a perfect square trinomial. In other words, a binomial that when squared, say x plus a squared, gives us the x squared minus 6x plus some random c. To do that, we're going to take half of since our coefficient of x squared is 1, in other words, the number in front of the x squared is an implied 1, since there's no other number there, and the only number that we could multiply by x squared and still get x squared is 1, then we only need to take half of the b term, the coefficient of x, the negative 6, and square it. So half of negative 6, or negative 6 divided by 2, is negative 3. And negative 3, when squared, well, that's negative 3 times negative 3, and a negative times a negative is a positive. We end up with 9. So what we need to do to make this a perfect square is not add 9. And if we're going to add 9 to one side, we must add 9 to the other side to keep our equation equal. So we end up with 18 equals x squared minus 6x plus 9. And now we know that x squared minus 6x plus 9 is the perfect square of, sorry about that, x minus 3 squared. I can prove that by saying x minus 3 squared is equal to x minus 3 times x minus 3. To multiply two binomials, we can use the FOIL method. You may remember that stands for first, outer, inner, and last. So to multiply the first term by the first term in each binomial, x times x gives us x squared. Outer times outer, well, that's the outer part of this binomial by the outer part of that binomial, or x times negative 3, which is negative 3x. I stands for inner times inner. We again have a negative 3 times x, which is negative 3x. And then last times last, which is a negative 3 times a negative 3. We've already discussed, gives us a positive 9. So we end up with x squared minus 3x and positive 9. Combining our like terms, negative 3x and another negative 3x becomes more negative. We get x squared negative 6x and positive 9. So yes, x minus 3 squared is the square of a binomial that gives us the perfect square trinomial x squared minus 6x plus 9. So now we've got we've found the perfect square. I'm going to rewrite it in the other form, just swapping the equal sign. We've got x minus 3 squared is equal to 18. To simplify this, or to try and solve for x, we're going to first have to get rid of that square on the left-hand side. And to undo a square, we square root both sides. So we end up with x minus 3 alone, because the square root gets rid of the square on the left side, and on the right side we're going to end up with the square root of 18, but it's going to be the positive or negative square root of 18. And you ask that, why do we need to put a positive or negative there? Well, if I were to say that x squared is equal to 16, you would say, well, then x must equal 4, because 4 times 4 equals 16, right? But what other number, when squared, could give us 16? And by now you've probably guessed, well, that would be negative 4, because negative 4 times negative 4, a negative times a negative is a positive, so again, it also gives us 16. When we solve, when we've been given an equation that says x squared, or a variable squared, equals a number, then we have to remember, when we solve that by taking the square, we have to find both the positive and the negative of that solution. So it's not that x equals 4, it's that x could equal either positive or negative 4, because either one could give us 16. So again, back over here, we have either positive or negative the square root of 18. We still have to do a little simplifying here, because the square root of 18 is not simplified, and that is because we've got the positive or negative. 18 could be broken into, well, what perfect square goes into 18? Well, our perfect squares, 1 squared is 1, so 1 goes into 18, but that doesn't really help us any. 2 squared is 2 times 2, or 4. 3 squared is, and 4 doesn't go into 18. 3 squared is 3 times 3, which is 9. 9, however, does go into 18, so 9 goes into 18 twice. 9 times 2 gives us 18. And when we have multiplication underneath the radical of a square root, we can break it up into two separate square roots, so that we end up with x minus 3 equals positive or negative square root of 9 times the square root of 2. And square root of 9 we can solve. We know that the square root of 9 is 3. We've already got the positive or negative in front of it. So we have x minus 3 equals positive or negative 3 times the square root of 2. We can't solve. I mean, we could come up with an approximate, but we're going to leave our answer in the exact form, which is the square root of 2. We're almost done. We want to solve for x, remember? So to finish this off, to get x by itself, we have to add 3 to both sides, leaving x by itself. And over here, we'll have a positive 3, because we've added 3 from the other side, plus or minus 3 root 2. So there are two solutions to this problem, two locations where the graph of this equation would cross the x-axis, and that is when x equals the positive, or 3 plus 3 root 2, and when x equals the negative of that, x equals 3 minus 3 root 2. Thank you very much.